while the slides are being posted here, I want to first of all thank Mike and others at TCEQ for putting together this workshop. It's clearly a timely topic, and as I was already indicated earlier on by Mike, the intent originally was to dedicate an entire session to talk about the secondary, and obviously once the proposed rule came out and the proposal in there to keep the secondary in the same form as the primary, but while still proposing to lower it, kind of shifted the focus a little bit. But having said that, I still think there's a lot of value in kind of walking you through what the proposal currently is, give you a little bit of background about the welfare NAAQS as it relates to ozone, and kind of keep that in mind because we are on this continuous cycle, and if we don't talk about it this time, I'm sure we will in a few years from now. So as Mike said, I am an environmental toxicologist and environmental risk assessor with Gradient. As you probably are very much aware, the NAAQS consists of two parts. The secondary is there to provide public welfare protection, and that can include, protection against decreased visibility, damage to animals, crops, vegetation, buildings, and ecosystems. So what I wanted to do today is, since we're talking about ozone, explain a little bit about the types of welfare effects we're concerned about when we talk about ozone. It includes visible foliar injury, effects on growth in trees and crops, and associated ecosystem services, which I'll explain in a bit. And then I want to, as we heard earlier, there's multiple parts to an NAAQS, and so I want to talk specifically about the form as well as the level. Since I think I want to try and bring that together in the end as we talk about the proposed rule and how the science informs both what form to use and what level to use with respect to the welfare NAAQS. And so, you don't have to be a plant physiologist to understand that plants get exposed to ozone differently than we do. But they do have little mouths on their leaves. They're called stomata, and ozone can only exert its effect once it actually enters into the plant leaf, and it does that during normal gas exchange. And once it's inside, obviously ozone, since it's a reactive molecule, it could also produce different secondary products. And you could see a range of symptoms in plants that are exposed to ozone. And, it could mean that they produce less chlorophyll, so you'll see a change in the green of the plant. You could see parts of the leaf discoloring, and so there's a range of names here: flecks, stipples, bronzing. Essentially, the plant appearance changes. And what's very important here is that this type of changing of colors of leaves obviously happens for a whole range of reasons. Naturally, different types of stressors, and it's impossible in the field to distinguish one from the other. So the only reason we know that ozone can have these types of effects is because we can do controlled exposure studies where we expose the plants to higher or lower concentrations of ozone, and we can see these symptoms occurring, or we can make them go away. Now, the second and probably most important endpoint that is being considered, certainly most important with respect to trying to inform what would be an appropriate level for the welfare NAAQS, is effects on growth. And again, the way you get effects on growth, obviously if you have ozone coming into a plant, it's affecting photosynthesis. That's going to result in lower growth. Additionally, obviously, if somehow ozone results in stress on the plant, it's going to have to dedicate energy to that process, and it takes it away from allocating it to growth. And this, again, this is not new. We've known this for decades. I show a slide here, or a figure here at the bottom right, going back again to, as I show here on the figure, these are an example of an open-top chamber where you can essentially kind of control the exposure of the plants. And so we've known for a long time that if you expose crops or trees to increasing levels of ozones, that you can reduce the growth potential of those plants. Some of the database and the studies we have available really haven't changed much over the last 30 years. There's been not a whole lot of new science being generated. Again, getting back to to the research dollars. Good luck trying to get money doing a lot of ozone work these days. And then thirdly, and this is maybe a little bit of a newer thing that's being considered in the welfare process, is EPA, not just for ozone, but for other criteria pollutants, has started to look at what it calls ecosystem services, and I define it on here. It's, again, it's public benefits that we essentially receive from nature. Those could be provisioning services. We get crops, obviously. We get timber production. That could be regulating services that nature provide, sequestering carbon, the role of vegetation in climate control, aesthetic enjoyment, recreational value of forests, and supporting services. And so, as I said, EPA has been incorporating this concept of ecosystem services into the welfare risk and exposure assessment for ozone as well. It is hard to quantify these things, but it's at least making an effort in trying to bring this in the picture. And so in summary, and I'll talk through those three endpoints, the foliar injury, the biomass effects or the growth effects, and the ecosystem services in a bit more detail. Just wanted to give a brief introduction. But to the form of the welfare, and as I said, initially there was a little bit more of a focus on the secondary because it was unsure whether EPA was going to move forward and actually propose a distinct standard that would apply to welfare. And again, you don't have to be a plant physiologist to understand that a plant gets exposed differently than we do. And so there's a reason, or there could be a reasoning why you might want to have a form to measure exposure in plants that's different than how you would measure exposure in humans. The exposure would happen over a growing season. You would look at exposure throughout the day, and you would give greater weight to some of the higher exposures that occur. And the reason for these types of metrics that are called biologically based is that if we go back to some of these older studies that I've shown, if you try and draw curves through these data or try and relate the exposure that's occurring to the effect, you actually get a better prediction if you account for seasonal cumulative exposures and you weigh concentrations at the higher end greater. And so you can form fit the data better if you have so that's really been the driver for trying to have a biologically based secondary standard form. Having said that, this is an area of research that is still very much evolving. We're not just dealing with one species here, we're dealing with thousands of species. And so there's a lot of variability. There's also a lot of understanding that's been growing about how ozone actually gets into the plant and how exposure actually relates to dose. And so at this point, really the takeaway message is there's no perfect equation here to relate exposure to effect for vegetation. There's been several forms that have been considered. For example, on the figure I have here at the bottom left, I put the equations in there as well, but essentially two of these are what are called threshold weighting, and so the AOT 40 and the sum 60, essentially hourly concentrations below 40 part per billion are not accounted for in the AOT 40. They're lower than 60 are not accounted for in the sum 60. So it's really just a binary weighting. So you would weigh any concentration or any exposure above 60 at 1, below 60 at 0. And then the third I show here is more of a gradual weighting where you would give weight to exposures that occur up till, 40 down to 30 part per billion, with kind of an inflection point around 65 part per billion. And that is the W126, which is the form that was used and was being considered in the current review. And so to finish this, piece on the biologically based or a different form for the secondary, over the last two reviews, EPA has gone through the process and saying, well, we think we should have a biologically based way of relating exposure to effects in plants for ozone. However, when it starts looking at air quality analysis and looks at the primary average form and these alternative forms, it sees really good overlap. And it says, well, while we can maybe all agree that it would be better to look at exposure and effects using a W126 form. Really, for the purposes of trying to regulate air quality, we can just do that with the current form. There's no need to have another different form so we can get the same air quality. And so based on that, it has consistently gone back and said, let's just leave it the way it is and have the same standard. It did acknowledge last round that there's some uncertainty that remains, whether in practice having this 8-hour metric would provide sufficient protection, and I'll talk a little bit to that. So that was just a very brief introduction about welfare and ozone. So now let's dig a little bit into what is happening in the current review. What is the science saying? What should the level be? What should the form be? And obviously, EPA's conclusions and the administrator's proposal, as is listed out here, is to state that the form should remain the same. It should be identical to the primary, and that's mainly based on air quality analysis, and I'll briefly show you the information that supports that. Secondarily, though, it is saying that based on the welfare risk analysis it's conducting in the current review, it concludes that the current level is not protective of vegetation and should be lowered. And so it's saying it should be lowered to 65, to somewhere between 65 and 70 part per billion, similar to the primary. And then it estimates that that would kind of equate to a W126 level of around below 13 to 17 ppm hours. And so that's what's in the current proposed rule. And so I'll walk you through both the form and the level. I'll do the form first because I agree with that. There's a range of air quality analysis, as EPA did in previous reviews. Essentially, you look at available data that has been monitored over the last years. You calculate out exposure, either using the current form, which is used for the primary, or you use this 3-year average annual maximum 3-month sum of weighted daytime concentrations. If you do that and you plot these things out on graphs, as EPA did, I pulled 2 graphs here and I've listed the sources of all these in case you want to read up on it. On the left side, I show a graph that's relating the W126 standard. So you're essentially expressing air quality in the W126 cumulative standard that EPA is considering as an alternative on the y-axis, and on the bottom axis you're expressing it in the current standard form. And as you can see, for the 2 time frames here, you get a fairly nice correlation between the two. EPA produced a second technical memo that was produced in 2014, where it looked at a longer time period, and it was kind of at CASAC request, where CASAC would say, well, can you look a little bit more at how these two relate? And so for the time period of 2003 till 2013, what EPA shows here is essentially, again, at the top you have the current standard form, the bottom is the alternative W126 over a 10-year period, and you see very nice association between the two. So this just shows you the trends in air quality over a 10-year period, and they correspond very nicely in both standards. And so essentially, based on these analyses, the proposed rule states that these two are highly correlated, as are relative changes measured between either metric. And one other thing, and it really is less relevant at this point since EPA is proposing to keep the form the same, but it does acknowledge that if at some point EPA decides to go with a separate form for a secondary, which would be kind of a sea change and a first, there would be unique implementation issues, and we've had a lot of discussion about whether we should think about implementation issues or not. Again, I'm kind of a common sense guy. I think it's ridiculous to look at the science and not think about how the science is going to be used. But clearly, if we wanted to go with a distinct secondary standard, I think we need to first understand what that would mean practically. And so I think, and this is the bold is my statement here, I think EPA is fully justified in proposing to retain the current form. I think the air quality analysis present a very convincing case that you can use the current form and provide air quality that is going to be protective of welfare. And you can demonstrate that by measuring it in this alternative form. Now, the level gets a little trickier. As I said, the main endpoints that EPA is looking at is visible foliar injury, ecosystem services, and effects on crops and trees. It conducts the risk assessment by looking at a range of scenarios. It looks at, well, what type of risks are we predicting for recent ambient air quality, and then what risks do we predict when we move to just meeting the existing standard of 75 part per billion, or a standard that would be set in the W126 form at 15, 11, or 7 part per million hours. And just, I mean, it's very confusing, obviously, to be talking about parts per billion and ppm hours. You know, for all intent and purpose, 75 parts per billion and 15 ppm hours are pretty similar, and I'll show that in a second, just to orient yourself. But and so in the proposed rule, EPA, on the basis of the analysis and the risk assessment it conducts, states that a W126 level somewhere in the range of 13 to 17 ppm hours would provide requisite welfare protection. We've already heard earlier, you know, requisite is kind of an interesting meaning here. But so that's kind of the range that EPA identifies as we should be somewhere in there to provide adequate protection for welfare. And so let's just go with that assumption, okay? 13 to 17 is fine. If I look at the air quality analysis that EPA conducts, and there's a lot of information on this slide, but I'll walk you through it. On the top left side, you'll see kind of the existing monitoring network for ozone. And then at the bottom left, I include a table taken from the risk assessment. And essentially what EPA is doing here is saying, well, we're going to model out what the W126 levels would be at these individual monitors if we reduce concentrations down to either just meeting the standards, which is the first line, 75 part per billion, or going down further to 70 or 65 part per billion. What I want to point you to is if you go from current conditions to just meeting the current standards, there are only 15 monitors in the entire nation that would be exceeding the 17 ppm hours that EPA has identified as the upper end. You could even go to 15. You only have 35 monitors, and all these monitors are located in this red box that is shown in the bottom right figure. And we've been talking a lot about the Intermountain West here already. I mean, the reason you're getting them there is for the exact reasons we've been talking about earlier. We've got significant issues with background contributions in those areas, let alone the fact that some of the W126 predictions in that area are trickier anyhow. There's not as many monitors, so you've got to extrapolate over bigger areas, so that causes some uncertainty. But I think the key issue here is that there is significant uncertainty and there's significant contribution of non-local sources coming from international transport, stratospheric intrusion, wildfires that cause these ozone concentrations to be predicted to be higher in the Intermountain West. And then, you know, one bullet I added here is there's something interesting as well on the actual effect side. Plants growing in these areas, in areas that have non-average climate conditions where it's drier, it's typically lower soil moisture, they actually are exposed to lower levels of ozone because they will close their leaf mouths because of these soil conditions. And so you can't just assume, again, that you've got this one number for the nation and then assume that a plant's the same everywhere. It just doesn't work that way. And so the point I wanted to make here, if we go with the 13 to 17 ppm hours, as EPA is suggesting, I would argue that their analysis show pretty convincingly that we are already compliant. The level is already requisite to protect welfare because you get concentrations, say for a few monitors that are pretty uncertain in the Intermountain West, and so there would be no reason to lower the level. Having said that, you know, I do want to talk a little bit about, well, where's this 13 to 17 coming from? And as I said, probably the most important endpoint in forming what the level of the secondary standard should be are these controlled exposure studies that were done decades ago with tree seedlings. And we continue to pretty much use the exact same data over and over again, every review. The only thing that was added this year was a cottonwood study that KSEC said was not very good, shouldn't get a lot of emphasis. EPA then said, well, you're probably right, let's do the analysis without cottonwood and with it. And we'll also take black cherry out because there's some uncertainties with that. And so they started identifying that, yeah, there's a lot of interspecies variability, one. There's probably some outlier studies, but the data are what the data are. What I'm going to point you to is that, well, we also have to recognize the uncertainties in the data and take that into account when we try to argue that lowering the standard by 5 parts per billion is going to somehow result in a measurable increase in welfare benefits. There were 2 additional phase studies, or they're free air concentration enrichment studies. So they're these studies that are conducted where you can actually control the atmosphere around the plants. Unfortunately, when you calculate out the exposure levels in those studies, they were well below or well above the range that we're talking about. So they're not that informative, really, for setting the standard level. And then finally, and this has been a long back and forth between CASAC and EPA and others, what is the threshold for relative biomass loss? What is adverse? Is 2% relative biomass loss in a tree adverse? I mean, nobody has really come to a conclusion here. CASAC has offered up opinion in the past saying, well, it should be 2%, maybe it should be between 2 and 6%. EPA actually acknowledges in the proposed rule that it doesn't really have a good scientific rationale for what it considers adverse, but it'll just go with what CASAC says. And so I want to just point out that these are arbitrary decisions in a way, and it would be nice to understand what exactly is considered adverse when we talk about this endpoint. Again, what I want to illustrate here is just give you a feel of the uncertainty in the welfare risk analysis. And I do this for the biomass loss, again, because it carries the most weight in informing the level, and it's really what EPA points to when it comes up with 13 to 17 ppm hours. On the top right is this data set of 52 studies. A lot of these date back 30 years. These are controlled exposure studies where ozone was increased, and you get a dose response going from left to right. The difference being here, it's expressed in the W126 form, so it's expressed in this cumulative form. And then on the y-axis, you go from 0% biomass loss to 100%. I mean, I have several issues with this approach. I mean, first of all, I don't understand why you would force the intercept through 0. There is no such thing as 0% ozone. And so forcing it through 0 just makes you get the answers you want in a way, because it'll actually show you to have greater reduction when you reduce the exposure concentration. So that's one thing, but I won't go into that. The second is that, you can look at this and say, well, that cottonwood and black cherry line sure looks a little different than the other ones. And so, as I indicated, cottonwood was not a controlled exposure study. It was a gradient study. And so CASAC identified this and said, well, you shouldn't give that too much weight. That is a single study. Some of these other species actually have 6 or 7 studies underlying them. Black cherry is another interesting species because you will continue to exceed 2% biomass loss, even if you go down to 3, 5 ppm hours. And so it is essentially very uninformative for setting a level that would be protective. And so I took these data and plotted them out at the bottom left, and all I want to show here is that you start removing 1 or 2 species of this data set, and suddenly you get very different answers. You take out cottonwood and black cherry, and the solid line, and I'll explain. So the solid line is created by, again, you take a certain exposure level, a certain W126 level, and then you can obviously look at the figure and see, well, what would be the predicted relative biomass loss for one of these species? And then you do that for the 12 of them, and then just calculate the median, and that's your median relative biomass loss. And you do this for all concentrations. That gives you that solid line. I did the same, but then I removed a few of these species, and obviously you see these curves come down a lot, which means if you used a 6% threshold, you'll get very different answers as to where you should draw the line for what is a protective level for tree biomass loss. Now, so we have some context here. The data are limited, and they are what they are, but I think it's important that we understand there's some uncertainties there, and you start removing one or two species, and you get very different exposure response functions. But having said that, there are a range of analysis where EPA took these curves and then said, well, let's just see what happens throughout the country. Let's see what biomass loss we predict across the nation, or specifically in Class 1 areas, and that's what I show here. Again, rather than taking a table, which I don't think really conveys the message, I just took the data from EPA's tables and put them in the graph because I think it illustrates the point better. If you look at nationwide, you use your concentration response functions and you look at what types of plants are present, you can come up with what EPA calls a weighted relative biomass loss. You'll see that about, and I can't really read the number from here, it's about 7%, I think, of the country would exceed a 2% benchmark under recent conditions. If we just meet the current standard, we go from 7% to 0.2%. And then going further down gives you very small and marginal further reductions. The same is seen in Class 1 areas. And so the point I'm making here is that, yes, there's uncertainties in the data set, but it would be hard to argue that you're not getting a substantial benefit from just meeting the current standard. It would also be very hard to argue that given the uncertainties in this data set, anything further down becomes meaningful. And so really that is my point here, is that I don't think the analysis presented in the risk assessment support lowering a level such that you would get any measurable further increase in benefits. You know, EPA did the same for foliar injury and ecosystem services, and I'll walk through those fairly quickly. Foliar injury really isn't a very good predictor or a very good endpoint to use to set an ozone standard. EPA says itself, ozone is not a good predictor of the presence or absence of foliar injury. Well, right there, that's probably not a good one to look at then, right? But having said that, you know, it recognizes there's a lot of issues with this analysis, but did conduct a screening level assessment looking at 214 national parks across the country. It developed a benchmark of around 10 ppm hours in its risk assessment. And when it adjusted air concentrations to just meeting the standards, the short of this analysis is that it concluded that all the parks in its analysis would be below the benchmarks it identified, and so there would be no issues in the national parks in this analysis. And so again, foliar injury, in my opinion, not very informative. Ecosystem services, pretty much the same thing. It is, a lot of these ecosystem services are really informed by the relative biomass loss analysis. What you're doing is you're looking at ozone, how does it affect crop yield or tree growth, and then essentially you calculate out, well, what's the price of a tree, what's the value of a crop, how much carbon does a tree sequester, how much air pollution does a tree remove. So essentially just, you know, using a calculator and multiplying these numbers, it's the same answer. And so, you know, I put on two graphs here, but you get the same picture for these other endpoints. Going from recent conditions to just meeting the current standards gives you a substantial benefit. Going beyond that is really small incremental benefits that I would argue are uncertain and wouldn't support lowering the level. And so on the level of the standard, you know, I would argue that the current data and the current risk assessment do not support lowering the level. I think it's important to point out that we will see substantial benefits by meeting the now current standard, and I think EPA shows that in its analysis. You know, again, I've shown some of these graphs, but I think visually they're just, in my opinion, so convincing. On the bottom left, you see air quality, measured air quality, 2006 to 2008. If you adjust air quality for just meeting the current standard or these different W126 levels, you see a substantial shift to the left. Air quality gets substantially better if we go from current conditions to just meeting the standard. If you look at it on a region-wide level in the country, you'll see here monitored concentrations in the first column and then concentrations modeled by meeting the current standard. a lot of regions have concentrations that are well below 7 ppm hours. So we're way below what EPA is saying. So we're going to see substantial benefits in welfare by meeting the current standard. That gets me to my conclusions. You know, I think with respect to form, as I indicated, I think the current form is perfectly capable of providing welfare protection equivalent to this alternative secondary form. I think, however, that lowering the level of the secondary standard is expected to only provide marginal and uncertain benefits beyond what is going to be provided by just meeting the current standard. And I think with that, I'll take any questions.
Any of the policy people want to ask a couple of quick questions? I need you to use the microphone.
I'm Don Arbuckle. I have a question for Roger. At the very end of your talk, you mentioned that context was all. And then you added a comment about political judgment not being the same as, and I wasn't quite sure of what.
Common sense.
Oh. So could you talk about that? Could you add?
Well, I think, you know, we blow away all the detail in what's written. When we come down to the proposal, my view of the proposed rule, all the proposed rules are written to lead the reader in a particular direction. And I think that direction, you know, they are excessively subservient, if you will, to the CASAC opinion. And so it's designed to elicit a set of comments which will be very polarized, by and large out of, you could say industry, but I'd say very heavily out of state entities, and you could see that in the map where those state entities are going to be. Those are the ones that are impacted. And they're going to say reaffirm, or the upper end. And then you're going to have the American Thoracic Society. They weighed in 60. It's a hand-waving commentary. 60 is obviously better. If they had suggested accepting comments on 50, they probably would have waved their hand and said 50 would be fine. And if you looked at the I attended the hearings in Washington, and they're very, very polarized there. The largest number were, you know, moms for clean air, and I didn't get my clean air T-shirt, and I didn't get the Sierra Club T-shirt, whatever. But they're designed to help give the administrator political coverage. We listen to your comments, and we come down at 65 or 70. I'm saying common sense says that the administrator has the latitude, she's going to be sued wherever she sets it, to use context in terms of look at this disbenefit. I mean, that's pretty compelling. Take a look at the recent paper that came out of the Southern California Children's Study. Excellent. There's no ozone signature there in terms of lung growth. In one of the most heavily polluted areas in the country, no signal relative to ozone. I don't know. They see one relative PM 2.5. I think I may understand that. I don't understand how they get it on NO2, but again, no signal out of ozone. That's one of the areas where actually there will be some substantial disbenefits in terms of ozone levels likely to go up if you try to drive down with NOx control. So I just, you know, to me, common sense is the broader context. I don't think you need to give so much deference to CASAC, and we give, you know, lots of reasons for that. If you look at these maps, if we put up a map of where CASAC members, statutorily appointed members, come from, they're right down the East Coast, with the exception of my friend Jack Harkema at Michigan State and Ron Wisna out in California. They're hardly representative of of the USA in terms of understanding the issue.
A basket of questions. Roger, given your vast experience here, and this is, you could go on and on for a bit. Well, I am interested, maybe we do it kind of offline at lunch, with your view on selection, operation, and management of KSAC and how it could be improved. Maybe we set that one aside. I am interested also, the closure letter noted that the agency hadn't given advice to KSAC regarding background, and whether your view on how that affects their determinations. And then finally, Tim did just a terrific job talking about form of the standard and averaging time. And as you rightly noted, the standard and stringency is made up of 4 distinct pieces. And I'm just wondering, in the health standard area, whether you think KSAC has properly reviewed and correlated variations to form and averaging time, different alternatives to the data that's presented.
Well, I'd say the answer is absolutely no with regard to statistical form. It's kind of an afterthought, and quite frankly, I think most people on KSAC, by that point in the process, their eyes are blurred over. They're so focused on a number that to think about statistical form, they just can't get their arms around it. And we can probably have some discussion with Bob Phelan later. He's been involved in these, a member. No, that's a difficult issue for people to come to grips with, is the statistical form. The problem is too complex for them. Now, what I'll say with regard to the secondary is when KSAC in 88 to 92, my recollection is we had one individual on KSAC that was kind of represented the ecological community. And I'm embarrassed I don't remember his name. Very distinguished scientist, North Carolina State University. Had many enjoyable lunches with him, member of the National Academy of Sciences. There's an awful lot of ideological orientation. Sort of, guys, we ought to get our turn, You health guys, human health, you're always getting your turn, but we're given short shrift. It's so kind of near the end of the process and kind of looks like it's going to be, well, let's just set secondary equal to the primary, and we're not, our science is not getting its in the spotlight. And so there's more and more pressure, and so the pressure built up in this review, we've got to have our form, ours, ecological, biological based. Let me give you a little bit of, remember on the front of the National Archives, something like the past is prologue. What may be past in terms of ecological may be prologue with regard to what you see in human health effects. And some people after this meeting will probably call me up and say, why in the hell did you bring that up? Well, biologically, something like a W126 makes a lot of sense with regard to human physiological, pathophysiological function. Those higher exposures probably are more, quote, damaging and have more residual effect than the lower ones, whatever. So don't be surprised if next time around we see some agitation out of some people in the health community, human health community, to want to go to perhaps something to complement the 8-hour one. And that's just the way it may happen.
One quick question from someone on the audience. Section 109 of the Clean Air Act says that KSAC is supposed to advise the administrator of any adverse public health, welfare, social, economic, or energy effects which may result from various strategies for attainment and maintenance of such NAAQS. So KSAC is supposed to provide the administrator that information. Do you think KSAC, as it currently operates, could carry out this duty?
Well, first of all, I think KSAC makes reference to that in their, quote, their closure letter by saying, We were not asked to provide that advice. If the administrator would like for us to give that advice, we'll be happy to tackle it. I would, be so bold as think CASAC, I think, ought to be more broadly thinking, and rather than just, they are so caught up in this causality. Speakers this afternoon, I apologize for this statement, but they are so caught up in the causality issue, getting a bigger and bigger basket of health effects that are, quote, causally or possibly causally related. Guy at the butcher putting his hand on the balance pan, makes it look bigger and bigger. I don't really think that's the case, but they've done that. So what I challenge CASAC is, why don't you take a look at those diseases and see what the pattern of morbidity and mortality is across the United States, how variable it is. How has it been changing over time? And then give that to the administrator. That'd be extraordinarily valuable perspective. When you see these huge differences across the country, should you be coming in now with a tack hammer and tacking in place this new standard that likely have no real effect on human health? It's the perspective of an individual who's looking at the continuum from sources to pollutants to disease. Individuals who start at this end and their focus is on sources, they have an exaggerated view, usually, in my opinion, of the impact of that risk factor on diseases. People over here looking at disease and its improved diagnosis and prevention, they see it as much more complex. Diseases are complex. CASAC, I don't think, fully appreciates that.